Welcome back to the course of Apparel Production Management. We would now be covering Unit 5. Welcome to the unit on WIP and throughput time. In this unit, you will learn about the calculation of WIP and throughput time used in production systems. This unit comprises of two modules and a final review section that invites you to reflect on what you have learned. Module 1 would be covering WIP and Module 2 would be covering throughput time. By the end of this unit, students will be able to define the clothing production terms, throughput time, WIP, etc. Illustrate the effect of WIP on throughput. Give examples from garment industry to illustrate the concepts. The first module reviews the effect of WIP on production with suitable examples from the garment manufacturing industry. Let us look into what is defined as WIP. It is the abbreviated form of the words work in progress or work in process. Partially completed goods, parts or sub-assemblies that are no longer part of the raw materials inventory and not yet part of the finished products inventory. WIP refers to number of garments that are under production at any given point of time. Throughout conversion of material to finished goods, garments are at different stages of completion and all are considered work in progress. Work in process inventory forms a part of the working or current assets of a firm and is valued usually at a lower cost and realizable value. Let us look into detail on what is WIP in a sewing room. WIP in a sewing room refers to all those garments which have been started but not yet finished. For example, in the garment manufacturing industry, WIP would include fabric that has been spread, garment parts sewn, finished garments which may have been packed, etc. Let us look into the term WIP levels. Acceptable level of WIP in a system depends on various factors like product type, production system, and management's or supervisor's capability. WIP levels can be measured as number of pieces or as time. It can be 18 to 24 days, but in a well-managed modern factory, it may reduce up to 4 to 12 days depending on the factors that were listed. Let us try to understand WIP controlling. WIP needs to be controlled as apparel factories face the major following issues. The major issue of higher throughput time, shorter lead time, less effective use of working capital, more storage space, that is, higher the WIP, more the storage space required, quality control difficulty, complexity of multiple styles, and less flexibility in the system. Let us look at the advantages and disadvantages of higher WIP. The only main advantage would be reduced waiting time and lower unit handling cost, whereas the disadvantages are pretty high. Higher the WIP represents higher money stuck inside the system. Lead time is increased. There is higher chances of garments being altered or damaged or repaired. Stress of the operator can be increased because of high WIP. Let us now look at some ways to control WIP inside the factory. We need to educate the supervisors and the workers and make them understand the importance of WIP. We need to measure and control the current WIP. We need to set a target for WIP for each production process, product type or a factory. A target should be agreed on for the amount of WIP, that is work in progress, required. Once the target is set, we need to plan and communicate to all levels. We then need to consistently monitor the levels of WIP across departments and across the factory. Now here comes the control part. Now that we've ascertained the level of WIP that needs to be kept across the system, we then need to identify where there is too much WIP or where there is too little WIP to take correct action. WIP can be calculated for a department, for a line or for an operation. Work in progress of garments for a department can be expressed in the number of pieces by recording daily production figures between each process and accumulating the difference between sequential processes. For example, if we have to cut 12,000 pieces but sew only 7,000 pieces, then WIP in sewing will be increased by 5,000 pieces on that day. WIP can be converted to number of hours or to number of days pertaining to how we follow our system. The general doubts that arise when we talk about WIP, let's discuss those. Now, you might have the doubt, why should the WIP not be too high or too low? Well, some WIP is planned to keep the plant operating smoothly. But if there is excessive WIP, it automatically reflects in the throughput time. That is, it increases the throughput time, it reduces the productivity, it limits a firm's flexibility and market responsiveness. Generally, WIP is noted pretty high in PBS, that is Progressive Bundle System, compared to UPS, that is Unit Production System. Why is that? The PBS philosophy, that is the Progressive Bundle System philosophy, adopts the high work in process or keep the operator busy task management. So eventually the WIP tends to be higher in a PBS system. Let's look at an example. If an operator can sew 200 dozens works per day, regardless of the production of other operators who produce, let's say, 120 to 150 dozens daily. So every day that particular sewing girl or guy produces an extra 50 to 70 dozen work pieces left over because others could not cope with her capacity. if we let this be, after 5 days, the extra builds up to 250 to 350 dozens. So, WIP was increasing daily. Now, due to this scenario, the manager has to get additional manpower to work on the slacks. UPS systems, that is unit production systems, cause a reduction in WIP levels, that is work in process levels, and change in the management philosophy of an apparel plant from high work in process levels to low work in process levels, which allows a quick response. In a unit production system, that is UPS, every workstation will hold a maximum of few garments per station. So, a great reduction in work in process as compared to the bundle system plant, where each operator has hundreds of pieces as WIP. In UPS, all finished garments are transported automatically between workstations and can be balanced. Let us now go to Module 2, wherein we would be discussing in detail about throughput time. What is throughput time? The period required for a material, part or subassembly to pass through the manufacturing process. I repeat, throughput time is the period required for a material, part or subassembly to pass through the manufacturing process. The concept also applies to the processing of raw materials into a component or a subassembly. The time required for something to pass through a manufacturing process covers the entire period from when it first enters the manufacturing unit until it exits the manufacturing plant. Throughput time, or to put in simpler terms, manufacturing cycle time, consists of 4 major parts. The first one is process time, inspection time, move time, and queue time. Process time is the time period during which work is performed on the product itself. That is the value adding part of it. I repeat, process time is a time period during which work is performed on the product itself. The second part of it is inspection time. Inspection time is a time during which the quality of the product is confirmed. Next is the move time. Move time is the time during which materials or work in processes are moved from one workstation to another. And last comes queue time. Queue time is the period of time during which the product awaits transfer to a workstation, undergoes further inspection and subsequent manufacturing processes. Regardless of the production strategy, throughput time is an important factor which impacts the planning and management of the conversion process. In the context of apparel manufacturing, throughput time is the amount of time it takes for a single unit of a style to go through the production process, let's say from cutting to shipping. This includes the actual processing time plus the time a style waits to be processed ahead of each operation. Throughput time impacts lead time and the total cost of producing a garment. Throughput time may be in minutes, days or weeks, depending upon the WIP in the line. Higher the WIP in the line, higher the throughput time, whereas lower the WIP, lower the throughput time. Now you guys know how WIP has a direct effect on throughput time. For a factory with constant throughput, WIP and cycle time are proportional. If throughput is held constant, it is impossible to reduce average WIP without reducing average cycle time, and vice versa. So, cycle time is generally reflected by the following formula, that is WIP divided by throughput time. Let's take an example of a hypothetical garment which has 11 operators named A to K and having SAM of 19 minutes of individual operation SAM, and WIP status is described. Insert table. Throughput time for any garment which will enter in the line is the addition of process time, which is equal to the SAM value of the garment and waiting time. For example, between operations A and B, there are 250 garments as WIP. So, after performing operation A, the garment has to wait for 250 garments for operation B, or garment has to wait, let's say in minutes, as 300 minutes. Why? The number of garments into SAM value of that particular garment. Let us try and calculate the time taken. Total throughput time is calculated with the following formula: process time plus waiting time. Waiting time for operation B would be calculated with the following formula: standard allowed minutes for that particular operation, that is SAM, into work in progress. So, the SAM value of operation B is 1.2 minutes and the work in progress mentioned there is 250 pieces. So, the waiting time would be 1.2 minutes into 250, so 300 minutes. Similarly, the waiting time for operation C is SAM of operation C, that is 1.6 minutes into 250 pieces, that is equal to 400 minutes. Waiting time for operation D is equal to 3.4 into 250 pieces, that is equal to 850 minutes. Waiting time for operation E is equal to 1.7 minutes, that is the SAM value of operation E into 250 pieces, which is 425 minutes. Waiting time for operation F would be calculated based on the SAM value of operation F, which is 2.4 minutes into 250 pieces, that is equal to 600 minutes. Similarly, for operation G, it would be 225 minutes. For operation H, it would be 200 minutes. For operation I, it would be 675 minutes. And for operation J, it would be 325 minutes. And the final operation K would be taking 250 minutes. So, now that we add all the waiting time, so the total waiting time is equal to 4250 minutes. As we discussed earlier, process time is calculated by the following formula: total SAM value into bundle size, which is equal to 180 minutes. Total throughput time is equal to waiting time plus process time. So, the calculation would be 4250 minutes plus 180 minutes. So in total, the throughput time for one particular garment to come out of the line will be taking 4430 minutes. Let us also look at another question here. A line consisting of 15 operators is manufacturing ladies' top. I repeat, a line consisting of 15 operators is manufacturing ladies' top. Line has straight line flow and is perfectly balanced. There is one operator at each operation and work content of each operation, that is the SAM value, is at 75 seconds. The flow is manually moved hangers where all parts of a single garment is kept in a single hanger. The operations are carried out serially and no parallel processing on particular garment is taking place. Now in this scenario, if there is no buffer stock between operation, then let's try and find out the throughput time of single top in the sewing room. Now if we keep a buffer of 30 minutes between operations, that is no buffer at the feeding point but continuous supply of 12 hangers after 15 minutes, every 15 minutes, then find out what is the total WIP in pieces in the sewing room when the production is in full swing. Also, we need to calculate the throughput time of a single garment now. So, we have two scenarios. First, let us calculate the throughput time. Throughput time is calculated as process time plus waiting time. Throughput time without buffer stock is 15 into 75 seconds. That is equal to 19 minutes 15 seconds. So, the WIP in the line is 15 pieces. Total WIP in line would be calculated by 14 into 24, that is 14 hangers into 24 plus 15, which is a WIP inside the line. So, that is equal to 351 pieces. If we keep a buffer of 30 minutes in between operations, then throughput time of a single garment is calculated by the following method. 15 into 75 seconds plus 14 into 30, that is based on the buffer, 14 hangers, 30 minutes of buffer. So, the answer would be 439 minutes and 15 seconds. Now, let us look into a numerical in unit 5, that is WIP and throughput. We would now be doing a small numerical on throughput time. In this example, company A keeps track of the time relating to orders and their production. During the most recent quarter, the following average times were recorded for each unit. Here, the wait time is equal to 17 days. The inspection time taken for the order is equal to 0.4 days. The process time taken for this particular order is 2 days. The move time taken for this order is 0.6 days. The queue time for this order is 5 days. Now let us try to calculate the throughput time. I will write down the formula for throughput time which we have already discussed. Throughput time will be calculated with inspection time plus process time plus move time plus queue time. So inspection time given here is 0.4 days plus process time given is 0.2 days. Sorry, 2 days. Move time given here is 0.6 days plus the queue time here is 5 days. So in total, the throughput time is basically the addition of all these 4 major points in a production system. So the total here comes to 8 days. So the throughput time for this particular company is 8 days. You have now come to the end of this unit. In this unit, you have learnt about important apparel production terminologies like throughput time and WIP. You have also learnt the effect of WIP on throughput time.